Is information real, or is it just a mathematical shadow we project onto reality? When we say a bit of information, are we talking about something that exists in the real world, like mass, electric field, or are we talking about a quantity that only emerges when someone builds a model? Well, this is a serious epistemological fault line, because if information is directly measurable in the strong physical sense, then it belongs to the ontology of the world. If it is only computable, then it belongs to our description of the world. Let's start with the classical definition. In the theory of information developed by Shannon, the information associated with an event is defined as the minus logarithm of the probability of the event. So a bit of information is not a physical object. It is not a particle. It is not something you can isolate in a laboratory and place on a scale. It is the logarithm of a probability. And this means that the bit of information is not a primary quantity. It is a mathematical function defined over a probability space. Without a probability distribution, the bit doesn't exist. And here lies the crucial distinction. Measuring is not the same as calculating. To measure in physics means to compare a quantity to a standard using an instrument. Whatever, a meter stick, an atomic clock, a balance, whatever. To calculate means to apply a function to quantities that are already known. Well, you can't detect a bit, you compute it. That does not make it less rigorous. Well, Shannon entropy is a perfectly well-defined quantity. It is measurable in the mathematical and statistical sense, but it is not a microscopic property of an individual physical entity. Here a powerful analogy appears with Boltzmann equations of the thermodynamic entropy. So S equals K log W means that thermodynamic entropy is not a property of a single molecule. It is an emergent property of a statistical ensemble of microstates. In the same way, information is emergent. It is not a substance, it is a property of organization. And there is even a subtler point. The bit is relational. It exists only relative to an observer, to a model, a probability distribution. It is an epistemic quantity before it is an ontological one. Now, quantum physics complicates the whole picture here. In quantum information theory, the bit becomes a qubit. The von Neumann entropy can be estimated experimentally, and the principle formulated by Rolf Landauer tells us that erasing one bit requires a minimum energy dissipation. Now, here information leaves a thermodynamic trace. It is no longer just a formula. It is tied to energy, to physical processes. And now the ground shifts. John Wheeler proposed the famous theory, it from bit. Physical reality emerges from information. But we can also invert the perspective. Perhaps the bit is not the foundation of the world, but the metric we use to describe the organization of the world. And this becomes especially relevant when we talk about artificial intelligence. When a large language model like ChatGPT processes billions and billions of parameters, it is manipulating bits. But are those bits ontological information? Or are they statistical correlations computed over learned distributions? Perhaps information is not a thing. Perhaps it is a structure. a structure that emerges when matter becomes organized in a way that allows it to be compressed, described, and coded. In this case, information is not the substance of reality, it is the grammar of reality. And understanding the difference between measuring and calculating might be the key to understanding where physics ends and representation begins.